Good day everyone, welcome to another tutorial video in mathematics 10. Today we're going to study about remainder theorem. So let's start. Uh, Before we discuss remainder theorem, I just want to do some review on long divisions of polynomial. So if we ask to divide 4x cubed minus 3x squared minus 8x plus 4 by x minus 2, we will do the following steps. Let's divide the first term of the dividend by the first term of the divisor. That is 4x cubed divided by x. And we got an answer of 4x squared. Now let's multiply 4x squared to x minus 2. 4x squared times x minus 2, we have 4x cubed minus 8x squared. Now let's subtract this or just change the sign of the subtrahend and let's combine them. So we have 0 for 4x cubed minus 4x3. And we have positive 5x squared for this one. Positive 5x squared. Now let's bring down 8x, negative 8x. So we have this. Now let's go back to our first step. Let's divide 5x squared by x. We have 5x. Then let's multiply 5x to 5x. Let's multiply 5x to x minus 2. So we have 5x squared minus 10x. Now again, let's change the sign and add this. So we have 2x, then bring down positive 4. Now 2x plus 4 divided by x, we have plus 2, positive 2. Now 2 multiplied by x minus 2. And our answer is 2x minus 4. Now let's change the sign of this and proceed to addition. And we have 8 as our remainder. So in this one, this will be our divisor, this will be our quotient, and this will be our remainder. Now to plot it in a division algorithm, we have this. Now I want you to pay attention on the divisor. We have the dx, d of x. This is the divisor, this is the quotient, and this is the remainder. Now focus on the d of x or the divisor. Now let's consider d of x, that is x minus 2. It is in the form of x minus c, where we have the value of c as 2. Now let's consider the polynomial expression. And let's substitute the value of c on the value of x. So p of x will become p of 2 multiplied by 2 minus 2 times 4 times 2 raised to 2 plus 5 times 2 plus 8, then plus 8. As you can see, if the value of c is the value of x, we will have this part of the algorithm to be 0. Now any number you multiply by 0, the answer will be 0. So therefore, if p of 2 of this polynomial expression will be equal to positive 8. So meaning, if we substitute c, the value of c, or the value of c, if the divisor is in this form, then p of c will be equal to the remainder. So that is the remainder theorem. That is the same as well if we substitute 2 or c on the polynomial expression without dividing it. So we have p of 2, that would be 4 times 2 raised to 3 minus 3 times 2 raised to 2 minus 8 times 2. And we have the following evaluation. Now let's multiply it, let's evaluate it again once more, and let's combine it. So again, we have 8, the value of p of 2 is 8. Now, what can we learn about this? Okay, now we can discuss about remainder theorem. The remainder theorem will help us determine the remainder of a polynomial in x, meaning p of x, when a polynomial p of x is divided by x minus c, without doing division process. So using the remainder theorem, we can say or we can find the remainder of a polynomial when divided by x minus c without doing any division. If the polynomial x is divided by x minus c, then the remainder will be is equal to p of c. Meaning, just substitute the value of c on x, then we will get the remainder. Let's have example number 1. Find the remainder when p of x is equal to 2x cubed minus x squared plus 2x minus 3 is divided by x plus 3. Let's identify first our c. That would be negative. Or if you're finding hard to find c here, let's equate x minus c into 0. So we can say that the value of c is equal to the value of x. If we equate the dividend into 0. Now let's equate x plus 3 into 0. Let's add and then subtract negative 3 on both sides. Then we have the value of x as negative 3. So, our c is negative 3. Now to check what is the remainder, all we have to do is to substitute negative 3 to the value of x. So we get p of negative 3. And that would be 2 times negative 3 cubed minus negative 3 squared plus 2 times negative 3 minus 2. Negative 3 cubed is negative 27. Negative 3 squared is 9. And if we're going to multiply 2 to negative 27, we have 54 minus 9 minus 6 and minus 3. Now p of 3 is negative 72. So therefore, the remainder when p of x is divided by x plus 3 is negative 72. So that's how easy to find the remainder in this problem. Now let's proceed to example number 2. Use the remainder theorem to determine the remainder when 4x cubed minus 3x squared minus 8x plus 4 is divided by x plus 2. Now we can identify first the value of c. Again, the value of c is equal if 2x, if we equate x minus 2 to 0, and that would be 2. So our value of c is 2. All we have to do is substitute 2 to the value of x, and we will find the remainder when this polynomial is divided by x minus 2. So 4x will become 4 times 2 raised to 3. That would be 4 times 8. Then 3 times 2 squared, that would be 3 times 4. The negative 8 times 2, that would be the same. And we have to evaluate it. And until solution, we get the value. Hence, the remainder when this one is divided by this one is 8. I'm sorry for my wordings here. It's somehow, I erase some parts of the final answer. So again, the remainder is 8 when the polynomial is divided by x minus 2. Find the remainder when p of x is equal to 2x raised to 4 minus x cubed plus 2x minus 1 divided by 2x minus 1. Again, let's find the value of c, and that would be 1/2. If you're having trouble in using this kind of method, you could just equate 2x minus 1 into 0, then find the value of x, because the value of x is equal to the value of c. So x is 1/2, so therefore let's substitute 1/2 to the value of x. Now 2 times 1/2 raised to 4 minus 1/2 raised to 3 plus 2 times 1/2 is equal minus 1. So let's try to evaluate it. So that would be 2 times 1 over 16 minus 1/8 plus 2 times 1. In this case, we could cancel this out 8 and 8. So 2 will cancel out 16. That will become 8. So this will become 1 over 8. And this will become 1. So we have now 1/8 minus 1/8 plus 1 minus 1. And that will become 0. So the remainder is 0, so there will be no remainder. Note, whenever the remainder is equal to 0, it means that the divisor is a factor of p of x. So if it is 0, meaning this one is a factor. Now let's proceed to example number 4. Find the value of k so that when p of x is divided by x minus 3, the remainder is 2. So we have an unknown part in our polynomial. So we are tasked to find the value of k so that if we divide this one, the remainder will be 2. Now let's try to find the value of RC first. And that would be positive 3. Now remember that when we substitute 3 to x to the value of x, the remainder would be 2. So that's in the given. So now let's substitute 3 to our polynomial. And we can find and we can evaluate this equation. P of 3 is equal to 32 minus 15. Now we know that P of 3 is equal to negative 2. Then the next step that we need to do is to equate the this one to 2. That would be 2 is equal to 32 minus 15k. Then let's subtract 32 on both sides to single out the variable k. And that would be negative 30 is equal to negative 15k. Now again, to single out k, let's divide both sides by negative 15. And that will give us a value. So if we substitute the value, so the question is find the value of k. But if we are asked to find the polynomial expression, just substitute 2k. So we have p of x will be equal to x cubed minus 2. Negative 2 times 2 is 4. 4x squared. Then we have positive 2x plus 5. This is our polynomial expression in the real polynomial expression. But since we were asked to find k, so we'll just stick to k is equal to our answer. Now example number 5. This is in an average kind of question in remainder theorem. Find the value of k so that when this polynomial function leaves the same remainder when divided by x minus 2 and x plus 1. So let's find the value of k. So, so the thing is, we have two divisor. And if these two divisor, if we divide this polynomial function with these two divisor, the remainder should be equal to each other. So let's try first to find the value of c. On x minus 2, the value of RC is 2. Or on x plus 1, the value of RC is negative 1. Now let's compute on each one. Let's substitute 2 on the polynomial equation. And we have the following answer. So P of 2 is equal to 8k minus 14. So that's the first evaluation. Now let's try P of negative 1. If we substitute negative 1, and if we're going to evaluate it, so that would become like this. See the evaluation. And we have this, and we have the value of 2k plus 22. Now remember that when dividing both of them, the remainder is the same. So it is safe to say that 8k minus 14 is equal to 2k plus 22. So using this, let me see. Let's put 8k let's put k on the left hand side, and let's put the digit or the constant term on the right hand side. So in that case, I will subtract 2k and add 14k, 14 on both sides. See, I subtract 2k plus 14k on both sides. That will make this cancel out. This will cancel out. Now, 8k minus 2k is 6k. Then 22 plus 14. Now let's divide both sides by 6 to single out k. So the value of k is 6. So that's all for our lesson about remainder theorem. I will try to upload some problems on remainder theorem and how to answer questions about it. But please stay tuned for our next video tutorial. That's all for today. Bye bye.